So I think we'll call on you when we get that point. Into
Yeah.
I guess this is the meet echo for the room.
Yeah, it just gives us a cleaner way to see the queue and everything. And the transcription, which, by the way, picks up almost everything we say.
Mm.
I've seen it at IETF where people are having a private conversation like here, and everything was showing up on the transcript. It's, Mike is live.
So I think we normally get quite a few more participants, don't we?
Yeah, we can give an extra 3 minutes.
Where's the QR code?
On the microphone over there.
Welcome to DNSSD. If you are in the room and haven't signed in yet, then please do. There's a QR code on the microphone if you want to use that.
We'll close the doors.
Thank you. Okay, let's get started. So yeah, welcome to DNSSD. And first of all, I will stop my laptop from echoing my voice back at me. All right, so welcome everyone. So as this is an IETF meeting, the note well applies. Please, if you've not read through what it refers to, please do so. It contains all the information that you need to know before you participate in the IETF. If you're in this room, please make sure to sign into Data Tracker, either from the agenda link or by using the QR code that's hanging on the microphone there. Just use the on-site tool if that's what you prefer. And remote participants, please make sure your audio and video are off unless you're speaking. Now, this is an unusual DNSSD meeting because we have 3 chairs. And David, this is going to be his last meeting. So, well, do you want to say anything now on that?
To clarify, this is my last meeting as chair. I'm not planning to pass away before the next one. But yeah, no, thanks everyone for all the service discovery. It's been a fun time. I realized that it's been 7 years since I started doing this. Time flies when you're having fun. And it was honestly a good time. So I'll take a second to thank the working group for, this has been an easy group to manage. We've never, like in my experience, haven't had any very complicated problems or participation. So it's been really nice. It's been a fun time. And if anyone's considering chairing a working group, I learned a tremendous amount. I became a manager a few years ago, and the lessons I learned while chairing were incredibly useful. So if anyone wants to talk with me after the meeting about that, if then they're considering potentially chairing, please do. I highly recommend it. I'd be happy to provide guidance.
I'm Stuart Cheshire from Apple. I'm sure other people are going to say the same thing, but I'll jump the queue and say it first. Thank you, David, for your service with this and all the many other ways you contribute to IETF.
And also, we have a new chair, so we have Florian. Do you want to introduce yourself?
Yeah, hello. I'm Florian. I have about 20 years experience running authoritative DNS servers. I'm currently employed by the RIPE NCC, where I run one of the root name servers, which is somewhat important for DNS. In my spare time, I work on the OpenBSD project, where we write an operating system for 29 years now. There I work on network configuration. I wrote a DHCP client, Slack client, those kind of things. I also worked on a validating stop resolver. So yeah, I've heard about DNS routing, IPv4, IPv6, all those kind of things. And my first IETF was in '95 in Buenos Aires. I looked this up. This was in 2016. So yeah, it has been a few years. I was at a few meetings. When the DNS Directorate formed, I volunteered to become a reviewer there, and it was really interesting. And I wanted to do more work for the IETF because I think this is really a neat thing that we have here. I really like the IETF. And when Eric asked for volunteers, I stepped up. So thank you.
Okay, let's move on. So, we will this is a normal IETF meeting, so we will need a note taker. Do we have any volunteers? Thank you, Stuart. That's straight there. It's very quick off the mark there. Would you? Fantastic. Would anybody like to back up Stuart when he is busy contributing at the microphone? Great. Thank you, Peter. So those are the links for the chat if you're not using the MeetEcho client, and hopefully you're already on that video link if you're remote. So useful links here for the working group. If you come back to this later, you can use those to follow those locations. We also have a working group GitHub organization, which is where we maintain our documents. If you have a new document for this working group, you can contact the chairs to get that set up there. Now, agenda bash. So this is what we currently have in terms of our agenda. So we plan to go through in this order. And at the bottom there, we have a new topic that was raised to the chairs very recently. If we get time, we will cover that as well. There was also, as you all have seen from the list, there was Taurus asked us present his topic as well. We didn't hear any interest from the list members in terms of wanting to hear that, which is why it doesn't appear here. Andy, you've joined the queue. Or is okay. Okay. Does anybody have any input on this agenda before we proceed? If you do, join the queue, please. Otherwise, we shall proceed. So first up is, what are we doing with SRP and update lease? Ted, would you be able to give us the latest, please?
So these documents, whoa, this is really tall, amazing. I prepped it for you. Thanks. I'm going to just deep rep it a little bit. So these documents are in auth 48 right now, which means they already have RFC numbers assigned to them and are notionally ready to go, except it turns out that the auth 48 RFC editor requests were somewhat large in a couple of different ways. One of them, some of you already know about. The other one I discovered after I talked to anybody here, so you don't know about it. So update lease I've actually finished reviewing, and that one's ready to go to the RFC editor, except that I want to make sure that I'm not going to send it to them until I've done SRP, just to make sure they're mutually consistent, because the terminology that's used in the two documents is actually not entirely the same. That's generally not a problem. SRP basically uses update lease for one thing, which is the format of the option. So we don't actually care that much if the terminology is synced, but there's no reason to create needless confusion. So it would be good to be consistent. SRP, it turns out, I went to get started on this yesterday, which was not a fun day. And discovered that the RFC editor had been a little bit overly enthusiastic about the scope of their edit. And they actually managed to kind of change the meaning of the document fairly significantly in the process of editing it. This is a thing that happens sometimes. The editors didn't understand why we formatted things the way we did, and so they thought, oh, this would be a better format, it's more compact. But compact wasn't what we needed in that place, and there were a couple other things like that. So basically, I just kind of looked at that and I was like, oh. And I didn't finish it yesterday. I'll get to it as soon as I can. It doesn't. I don't think it's going to be a huge amount of work. I just need to basically go through and redo those bits, and and then I'll send them both to the RFC editor. So the other thing to say about that, though, is that I don't think the changes to SRP will be substantial, but the changes to update lease actually are substantial. They are purely editorial, but the amount of changes is enough that I think it warrants more than just my eyes looking at it. So it would be good to get some working group review of the updated document. I think the chairs are probably going to ask for that. Basically, I wound up, it turned out that there was a lot of terminology that was inconsistently used. The term lease is used sometimes as a duration and sometimes as sort of actually what a lease is. And sometimes leases have times, and sometimes they have values, and sometimes they have intervals, and all kinds of fun stuff like that. The names of messages were different in different places in the document. So basically, that's a big edit. It's done, and hopefully I didn't screw anything up. That's all I got.
Thank you. So yes, following those auth 48 changes, we will circulate them to the working group list to check, so that you have the opportunity to check that the text is you think it works as it is. So let's move on to multiple queue types. So there was, you may have seen that there's some recent discussion on the list on that, which was driven by ESCO's comments on 04. So Ray, do you want to give an update, please?
Yeah, no slides on this one either. Yeah, essentially, we did a dash 04 during the last DNSSD session, wherever we were last time, Vancouver, I think it was. And that was incorporating some very useful changes from Peter Spacek that massively simplified basically the response generation. Peter had also proposed some client processing rules, which I didn't have time to incorporate at the time because I needed some clarification from Peter, but those also got incorporated back in September, and they're really quite straightforward and quite small. The changes just published this morning, as Chris just said, were in response to some comments from ESCO, and they don't change any functionality. They're basically just clearing up a little bit of language, so they are really very sort of de minimis edits. And I think we're probably ready to try and put it to working group last call.
So question to everyone here, do you have any comments on whether we whether you think we are ready to proceed with working group last call on this draft.
Yeah, Eskedijk. I think it looks ready to me, yes. Although I did have one comment on one of the topics I raised in my previous email.
Okay, go ahead. I'll
I'm
see
not
if I
sure
can clarify.
if you could clarify that here, yeah, because it mentions about invalid QTX values. Now, I looked up, okay, what can QTX be? So that's some RR type
Yes.
can be put in there. So if you look at I think the latest RFC that's linked to the IANA registry has basically 3 types of RR types. So there are, I think, Q types, they call it. There was meta types, and there was a third one. I think it was just called types.
Just probably data types.
Oh, data types, yeah. So
Yeah.
three categories. So yeah, so any of these 3 could end up in that option. So I think we want to say that only the Q types are valid there. Is that correct? So
Well, probably defer to Peter on this one, but I'll give my opinion first.
Right.
Which is that basically Q types is anything that can appear in the question section of a DNS header.
Yeah.
And that also incorporates effectively almost all of the data types. The meta types are a separate category that don't basically appear in DNS questions.
Mhm.
They have a defined range. So DNS implementers know that if the type number is between 128 and 255, that indicates it's a meta RR. So it is effectively only the opt RR and the ones between 120 and 255 which are not permitted in multi-Q type.
Yeah, so maybe we should be explicit about that.
Well, I have said specifically about 128 to 255. Everything else is permitted.
Right. Okay. Yeah. Now, if that's the case, then there are basically no invalid. Well, if you use a Q type, at least it will never be invalid, right? So
yeah,
only the meta are.
Yeah,
meta
and
types.
your other question about unknown Q types essentially is not an issue. DNS servers know what to do to process Q types that they haven't yet been programmed to understand.
Yeah, there was a very good pointer to that draft. Sorry, RFC. I didn't.
Yeah, 3597.
See that yet so far, but that's good. And yeah, I think the only question then, yeah, because yeah, it was a bit unclear what would be an invalid.
But well, essentially anything that's a valid Q type
QTX, basically,
in DNS terms is a valid QTX.
Yeah.
So it's, I suppose you could say that's slightly circular, but if it's in the Q type list, which also includes the data types, then it's valid.
Yeah.
This shouldn't. I don't think this would cause any concern to any DNS implementer who was seeing this.
No, but if it's basically the meta things are invalid and the rest is okay. So that's
correct.
Fine, I think. Yeah.
Petr Špaček, I see. I've looked at the text with the implementer hat on, and I think that from the server side, it looks okay, and I don't see any reason why it shouldn't work. But I'm concerned that we didn't get any feedback from the client side. So I would love to have some feedback from people who would be using that interface, because I can generate the message on the server side, but I can't really tell whether it's like easy enough to interpret on the client side, or whether there is some, I don't know, error signal missing or something. I can tell because I've never done any development on the stub resolver side. So it seems that the text is fine, but I would love to hear some feedback from people who actually do development on the client side to say, okay, we've looked at this, it is okay, or it's not, or we don't know, we have more time to, try to actually implement it, because we don't have any implementation experience. And this is the freaking DNS. So little details can just make it explode after we publish it as an RFC. So I think that a little bit more implementation experience, or at least proof of concept, little attempt to do something with it would be good before we, rubber stamp it. But having said that, I don't see any problem with the text. It's just I don't feel comfortable saying it should progress without more experience.
Thanks, Peter. So I see Stuart going up to the microphone. Also put yourself in the queue next time, please, Stuart.
Note taker doesn't have to do that.
Oh, fair.
Well, I am juggling multiple things at the same time. I can stop taking notes while I deal with the queue.
Fine.
I always thought that was one of the note taker privileges. Anyway, so I have not implemented this, but I have implemented a lot of client-side DNS code. I don't have any concerns about this, and I'm kind of looking at Ted, who does more of this work these days.
So was I.
So as chair, I think Peter raised a very good point that it's good to get implementation experience before we publish documents. So we'd like to invite anyone who's implemented this to come share their experience, or anyone who wants to implement this to tell us about that too. That would be super helpful. And if you're having issues getting, no, there you go.
Oh, Peter is ahead of me, so.
Well, no, he was, I think it was just before.
Oh, I see. Yeah, so I think this is a reasonable ask. It's not like we're in a tearing hurry. Obviously, it'd be nice to get it done, but it's something that, so currently, I mean, the whole motivation, the thing that made us revisit this after it lay fallow for like, what, 7 years, was that somebody actually did an implementation of a DNS resolver that used QD count equals 2. And that broke a lot of things. So from my side, I'm definitely motivated to make sure this works, and I already have a multi-queue type implementation that just uses QD count, so it shouldn't be that hard to add this. Mine, however, is the resolver side, not the, that is to say the resolving server side, not the, the DNS resolver side, as your document terms it, not the stub resolver side. So I believe Abton is either here or will be here. And I think he did the implementation, or somebody he knows did the implementation, might have been one of the other guys there, of the QD count equals 2 solution. And so it would make a lot of sense. And I think there's demand for that work to happen sooner rather than later. So maybe, I don't know if Abton is, I see somebody.
He just got in the queue.
Sweet.
Yeah. But before, yeah, go ahead, Abton, actually, if you're responding to Ted.
I'm jumping out of queue, yeah. So yes, true. I'm the original author of the OpenThread implementation of the DNS client. And yes, indeed, in the OpenThread implementation of DNS client, we have this optimization that we try to query force SRV and text together, check whether the server is capable of answering this. So that to optimize, basically the idea is that like these devices are thread runs on like resource limited devices, and overall is a low bandwidth network. So we want to avoid sending multiple messages if we can. If the server or resolver is capable of answering the 2, perfect. We get the answer, the 2 in one go. We can do the service resolution. If not, if for whatever reason it fails, we fall back and then send separate queries. And yeah, I agree. I think we should be able to adopt this new mechanisms. So I will probably we will probably, either me or somebody else in the team, if I can, I try to have a prototype implementation of this and see how it works. It would be probably implementation on both ends, right? Basically on the client side within OpenThread and on the resolver side on the OpenThread side.
Thank you, Abton.
Stuart Chesh from Apple again. I think this is a good discussion. I agree. Having real world implementation experience before we publish it helps check if there's something silly we didn't anticipate. So we can work with you, Abten, to get that done, hopefully quickly, so we don't block this document. And while I'm at the microphone, I'm going to introduce Francois Michel, who was at the IETF last time as an individual, and since then Apple has hired him. So now Ted and I can tell him what to do. So maybe Francois can add this to his long list of things.
Yeah, multi-queue types is 12 years old now. It can wait a little longer.
Yeah.
Just hope he doesn't get so old it gets to drink first.
Yeah. Thanks. And actually, before you go, Esko, I'm relaying a comment in the thread from Tommy Jensen, who said, I'm not quite clear from the text. If there are 2 additional queue types and only one of them mismatches, will the matching additional be included or none of them?
Sorry, can you say that again? I can't read it. Sorry.
Yeah, right. Zoom in.
Tommy, can you elaborate by what you mean by mismatch?
All right. And while Tommy is typing away from somewhere else, I'm guessing. Oh, there he is. Go ahead.
From section 3.2.2, it says if no mismatches are detected, the server must attempt to combine the individual RRs. But then it also says if any mismatch is detected, the mismatching additional response must not be included.
Yeah, so Tommy, I actually can't remember exactly what the text says and why there. So could you please take that to the list and I'll be sure to give you a response?
Definitely.
Well,
And then chiming in on my other comment in response to Petter's point about client implementations, if there's endpoints available and there's a hackathon at 122, I would be happy to join it.
Cool.
Awesome. Thank you. Okay, Eska.
Yeah, so my point was just that I saw a comment on the chat that needs to be relayed. So I don't know if we have Jabber scribes nowadays because we don't have Jabber anymore. Zulip scribes maybe. But
We've been doing it as chairs.
Yeah,
because
that
it's
would be
much
great.
less common
Yeah.
than it used to be.
Thanks.
Then we have Ben in the queue.
Ben Schwartz, Meta. I would like to see an example section. To Tommy's point, there are a lot of fairly interesting interactions here where you have multiple answers and one of them serve fails. What are you supposed to do? You have a bunch of answers. The first three fit in under the response size limit, but the fourth doesn't. The text addresses all of these things, but I think some examples would help.
Okay. Point taken, but I think I'd look for some guidance from the chairs on that because my concern is that that'll probably double the length of the draft.
I'd say examples are often helpful, but we can talk about it. If it's a huge pain, it wouldn't be a hard requirement. Or how strongly do you feel about that, Ben?
Examples showing the positive cases are easy, but there are so many exceptions that to document to actually show an example for all of them would I think be it would make the document a lot longer.
Sure. There's a combinatorial explosion. I am not suggesting that you try to cover every weird thing that could happen, but I do think that it would be worthwhile. There are no diagrams, I believe, other than the format. I think there's an opportunity to make this easier to understand. And yeah, it might be a few pages of diagrams. I think that's all right.
So for the notes, I want to just go back. There was a mention of the hackathon, and I'm going to ask if the chairs want to make a decision. I would support making a decision right now that we will make time at the hackathon next time for anybody who wants to come along and try this face to face. Now, if nobody shows up, we don't have to do it, but let's at least sort of put that on the calendar that's our plan for next time. Does that sound like a good idea?
Absolutely. And just process-wise, the chairs.
You can't agree. You won't be there. Ask one of the other chairs to decide.
I'm still here. You will listen to me until the end of this meeting, Stuart.
You're volunteering them to organize a hackathon event.
So what I'm hearing is that multi-queue types would benefit from having real-world implementations, and clearly having a hackathon at the next meeting will greatly help in us in achieving that. So yes, I'm supportive of having that as a goal.
Okay, I just wanted to put that out because I thought it was a good suggestion. So if we all know that we're serious about that, then we can all make sure that we've got code, and we can have interim meetings before that. We don't have to wait till then, but let's have that as our goal, that by the latest, the next hackathon, we'll have actually sat down and tested this code together.
Great. And one quick point on that is when folks do implement, if some of these corner cases end up being particularly tricky or not clear, please absolutely mention that on the list or on GitHub, because
Yes, please. Yeah.
I think you're absolutely right that putting every single combinatorial in the examples is not realistic. But if, let's say, there's one that multiple implementers stumble down, that would be a great one to highlight in the spec.
Indeed.
All right. And I see Puneet in the queue.
Yeah.
Personal remote.
Hi, Puneet from Google. I put the comment in the chat already. I think the draft should mention how it interacts with the UDP fragmentation. At a minimum, reference the avoid UDP fragmentation draft here and how that should affect the size of the response. Similarly, serve stale. I will +1 the request for examples, especially the resolver to auth cases, because this is in the DNSSD group. So I'm not sure how much interest it's seeing on the resolver to auth side.
Okay. Take your point about fragmentation. I'll look into that, but it shouldn't cause any interactions that any DNS implementer doesn't already know how to handle. On the question of serve stale, personal, I say hell no. Serve stale is an abomination that must die.
Okay.
And yeah,
I'll just add a data point that from our implementation, we see about like 0.1% or so of queries actually successfully resolving because of serve stale. So it has some value there.
Yeah. I know DNS implementers who wish that serve stale had never existed. It causes no end of problems.
Okay.
Yeah, I see Andre waving. Yes.
I think Peter's next.
Petr Špaček, I see. I've rewritten the text of the algorithm like a couple of months back, so to me it seems clear how it works, but excuse me, but quite apparently it's not clear. So I think that examples are in order at least like not just the happy path, but we should have at least some which show the weird corner cases when like one of the 3 requests serve fail, and now what? Now how do you combine it? Because then it will open the Pandora box, possibly a Pandora box of questions from the client side. So now how do we deal with partial failure?
Yeah, I might ask for your help with that, Peter, as soon as you helped me actually redefine the algorithm anyway.
Yeah, sure. I mean, I'm happy to provide the examples if I don't have to do the XML formatting.
No, don't worry, there's no XML.
So, Ted Lemon, I'm just going to provide a little devil's advocate here, which is that if the text isn't clear enough, then that's a problem with the text, and adding an example doesn't fix the text, which is what's normative.
That's fair. For me, the slight difficulty is I think the text is probably completely clear to any DNS implementer,
right.
And this room is not full of DNS implementers.
Right. Yeah, that's a fair point. So anyway, my point is that I'm not. Several people have chimed in and said yes, please examples. But personally, I think if we really think there's a problem that needs an example to explain, that we should fix the text. And obviously, coming up with examples and formatting them and making them look useful is a lot of work, and it's a big ask for you to just get this new task dumped on you. So it's kind of up to you whether you're willing to do it. I don't think the working group should demand that you do it because
it is a working group document.
Sure.
But
even so,
there should be a consensus on whether it's actually required or not.
Yeah.
I am cautious about it. Yeah, I'm sorry, I've just been thinking in the background, multitasking about Puneet's suggestion about fragmentation handling. My personal view, I don't think it should be called out specifically because DNS implementers know how to handle DNS fragmentation, already have specifications for that. But yeah. We've got Niall? Neil, sorry.
Neil O'Reilly. I'm a fan of a small number of well-chosen examples. I think the structure of the example space is probably best represented by a kind of tree, and picking nodes which are well-chosen pathological or successful cases may highlight changes that are needed in the text, but will certainly help
individuals like me who are struggling with compensating for the weird things that application libraries do and having to do in the application stub resolvers.
Yeah. Yeah, most of the, if you like, unhappy paths, to recoin a phrase, in this specification are not in the case of, yeah, if it's this, then go down to some massive great big subtree, and if it's that, go down to some other subtree. They're really much more like guard statements. Yeah, is if this condition fail, if that condition fail, if that condition fail, and finally get down to the end and everything's happy and it works. So it's not a balanced tree in any means, but it's basically this yes, no, yes, no, yes, no, yes, no, yes, no.
Cool. So just on the topic of examples, I think, Ray, we'll let you give it a try and see, and then you can say, okay, here are the ones. And then if anyone thinks that's not enough, then we can encourage them to send PRs. But I think like we don't need to pick today the exact number of examples.
Yeah. I think what I'll try and do is to actually put those into an appendix.
Yes,
so that they don't clutter the main text. And then if we decide we don't need them, they can be pulled out again easily.
Great idea.
I will defer to the chairs, Stuart Cheshire again. I'll defer to the chairs to keep track of time and decide when we need to move on. My thoughts about this, listening to the discussion, is there are many things that long-time DNS implementers know, but some of the people reading this document and implementing it may not be experienced DNS implementers because they're working in a different space. As we saw with the code that was written using QD count equals 2, and they wrote the client side and the server side, and it worked. And if it had not been caught, that could have caused interesting interoperability issues with other things. So I think some accommodation to the fact that there are newcomers coming to this field. I agree. Too many examples is not good, but getting the right balance there might be helpful. And I'm offering to help. You've worked on this for many years, so this is not just piling work on you. I think we can all help contribute that.
Thanks, Stuart. And regarding the time, so my thought prior to you saying that was, this is a valuable conversation. I wanted it to continue. I'm just trying to extract the maximum value from the meeting time. But if my co-chairs have another opinion, please intervene. Lorenzo.
I was just observing the contradiction between, well, DNS implementers already know how to do this, so we don't need to specify it. But this room is not full of DNS implementers, and this document is in this room. And so I sort of
that's not lost on me either. But yeah.
So yeah, so I guess I agree with Stuart, right? If we are presenting it here and standardizing it here, where people don't know how it works, maybe.
I mean, there are people here who absolutely are DNS implementers and for whom this will not cause any issue. There are a lot of people who don't know the protocol backwards here, who are also probably not the ones who will be implementing it.
And an easy solution that I might, like as an individual, suggest to you, Ray, is for things like fragmentation. One line of, by the way, sending more things could lead to fragmentation, and here's a reference to that spec, and that's enough. Then someone who has never heard of it, that's enough for them to go and read up more.
Yes, informative reference to that, yeah. I need reminding what the reference actually is because I don't have it to hand, but
that I don't know.
I have a really dumb question.
Uh-oh.
All of these DNS implementers who already know how to implement DNS, is that documented anywhere? Just saying. You know, I hate to say it, but I've noticed that my hair is getting grayer, and I think that's true of many of us. And if we really want the younger generation to know how to do this, you know, maybe we should write it down.
Thank you so much for volunteering.
Yeah, I think it's definitely in the wrong group now, Ted.
We is not this group.
Yeah,
so.
definitely in the wrong group.
Thank you for volunteering the DNS Hop group then, I see.
Okay.
Anyway.
I think it's time for me to leave.
Thank you, Ray.
Okay, so this is not the first time I've talked about this. It's been through a few iterations. Next slide. So we've been working on this advertising proxy thing, which we needed for Snack. And the thing about the advertising proxy is that it's being used in a context where there are multiple advertising proxies publishing the same data. And the way that MDNS handles conflicts is challenging with respect to that. In principle, mostly it ought to work, but we do see name conflicts that show up. So we've gone through a couple of iterations of how to address that and finally settled on the idea that our problem is not name conflicts, it's not noticing stale data. Name conflicts are a thing and they still have to be handled, but it's really the stale data issue that is what we need to solve for the advertising proxy. So we need to know if there is a real conflict, and if so, then we just handle it the usual way. We need to know if there's stale data, and if so, we need to chuck it. And we also need to, it's not so much that we need to know if we have incompatible current data, is that if we have incomplete but current data, that shouldn't look like stale data and it shouldn't look like a conflict. Next slide. So we've been doing some work on this. There's actually an implementation in current tvOS releases that does this. It's now an EDNS 0 option. There's actually a little bit of diff text in here that's maybe not appropriate, but basically we include a timestamp in the message in order to avoid having to do clock synchronization. We make it relative to transmission time and store it relative to the clock in the server. And we include a key tag, and that is used to identify the SRP client in the case of our particular implementation, but it could be any sort of key that has authority or ownership over the name. I use the term authority because it's essentially equivalent to authority in the DNS. Next slide. So for conflict detection and resolution, the algorithm is pretty simple. Basically, if we have a conflict, if we have data that doesn't have TSR and data that does, that's in conflict. If we have data that has TSR and other data that has TSR, but the source of authority is different, that's a conflict. Those are just handled the same way that MDNS conflicts are always handled. So we don't change any code to deal with that, other than just treating those as conflicts. If we have data with a TSR and we have new data with a TSR from the same authority, then it can never be a conflict. But if it's if the new data is more recent, then we chuck our old data. And if the new data is less recent, then we ignore it. So that avoids both. Basically, that means that we shouldn't ever either be publishing or have cached data that is knowably out of date. Next slide. So I mentioned cache and authority. So MDNS responders generally both have a cache and an authority database, and they're normally, well, I shouldn't say normally. Our implementation keeps them separate. I suppose you don't have to keep them separate. So we also have to deal with the case of local registration, right? And that's actually super important, it turns out. So with local registration, if we register data, it's not necessarily more recent than what we have in cache. And so if we see something that's in conflict with what we have in cache, or if what we have in cache is more recent, then we still flush the cache and probe, because we want to make sure that the data that we have in cache is actually still out there and being published. And if the probe returns a result of stale data, then when you register that information, you get a stale data response, basically an error. And so also, if we publish data and we receive fresher data, then that publication, there's still an outstanding transaction going on. And so we're going to get a notification on that transaction that the data that we published is now stale. Next slide. So in terms of implementation, so this has been out in the field for a bit, not a super long time, but it seems to mostly be working. Yay. And when I say mostly be working, I mean, the problem is that the old code also mostly worked, but had some pretty bad behavior patterns. And this is showing none of those bad behavior patterns. So that's really good. We're doing a lot less multicast traffic now. And we've also run into some issues with the API. So I want to talk about that. Next slide. So with SRP replication, if we get, suppose you've got two SRP servers, both of them are doing SRP replication with each other. One of them gets an update, the other one hasn't. So that's going to replicate the update to the other one. At the same time, the one that got the update is publishing the data. So depending on how the multicast stuff happens in your router, it can happen that the MDNS packet arrives at roughly the same time as the SRP update, the SRP replication update. And when that occurs, you can get into a situation where you're publishing new data at the same time that the old data is being received and causing a stale data error to occur. And so in other words, the stale data error is actually referring to what was in cache or what was published. You're now publishing new data, but with the current API, you can get that error and you have no idea whether it's the new data that you just published that's stale or whether it's the old data that you had published previously that was stale. It's just not, there's no way to indicate that in the API. Next slide. So I think that we actually need to take a really transactional approach to this, which is kind of a pain because this is more complicated. But basically the idea is that when we're doing an update, we may need to do the equivalent of like a begin transaction when we start doing the update. So like you might have multiple records on an owner name, and every one of those records based on the TSR approach has the same timestamp on it. We don't keep an individual TSR per RR type, but only per owner name. So and that works because normally you get all of those records in one, SRP update. But the API doesn't allow you to say, here are 5 records, and we need it to be able to do that. One way to do that would be to just have like a list of records that we pass in. Another would be to do a transaction. It doesn't matter which, we don't need to specify which, but I think we do need to say, this is an issue, your API has to deal with it. Then the other thing is that we need to be able to differentiate between the transaction that we're doing now and the transaction that we previously did, so that we know which transaction the stale data error is referencing, so that we don't accidentally treat new data as stale, and so we don't have to do some kind of weird heuristic to figure out whether or not the new data that we registered that got the stale data response was actually stale. So I think we have to have transactions to do this. And we haven't actually implemented this API yet. So when this happens, valid data can wind up getting flushed. The good news is, since you're doing SRP replication, there's already somebody publishing it, so it's not the end of the world, but it certainly is not ideal, and we need to fix it. Next slide. And then also, like, while I was thinking about this, obviously I came up with some other things that I'd like to change about MDNS, which aren't necessarily relevant to this draft, but I'm mentioning them here just because. Right now, when we replicate data with the new TSR code, previously when we were replicating data, we would both probe and announce on every SRP server. And that was a lot of multicast traffic. Now we're only announcing on secondaries. So we probe on the primary and we announce on the secondary. And then if we have an SRP server that for some reason stops acting as an SRP server, that doesn't necessarily mean that the data that was registered with it is no longer valid. There might be some other SRP server that is still publishing that data. And if we know that there is another SRP server publishing that data, we probably should not be sending goodbye packets because it has some bad results. We can wind up, if there's an ongoing query for that data, then the querier will see a remove event and probably won't see correct data again for an extended period of time, possibly as long as an hour. That's not good. Next slide. And by the way, it would have no way of knowing that that's what happened, and therefore no reason to like requery or something like that to check to see if it's really gone. So anyway, the point of this talk, it was partly to let you guys know how the new code works and what's in the document. This is actually the published document documents all of this except for the API stuff that I just brought up because I only discovered that recently. And so we really need TSR in order to be able to do advertising proxy. I don't think that advertising proxy makes sense without it. That's why I've been working on TSR and not advertising proxy. So I would like to ask the working group to adopt it. And then also it would be worth asking, you know, does it make sense to document the API changes? Obviously, I think it does, but I'm curious what other people think. And if we document the API changes, would that go in this document or somewhere else? So.
Stuart Cheshire, we could talk about this in more detail offline, but I just wanted to share one thing that occurred to me on the last thing you talked about suppressing unnecessary advertising. One thing that occurred to me, without needing a new API, we could make it so the code looks in the cache. And if it sees those records have been received from some other device in the recent past, then it concludes there's no benefit in burning more multicast traffic, sending the same thing again. And that would have the nice property that if the proxies are working correctly on the same link and they're seeing each other's multicasts, so we suppress the unnecessary thing. If for some reason there's a disconnection and something's broken, then we probably do want to announce. So that would, I think, cover both cases.
Good point. Can you maybe send a note to the mailing list about that so I don't forget? Or, you know, put in the notes, but.
Hi, Greg Choules, ISC. Perhaps just from my own clarification in my head about timestamping, you were saying that time is held as a relative since it's received because absolute time might not be the same on each machine. Mm-hmm. But then how do you define what is stale if the timestamps are maybe not the same on the machines doing the sending?
Right. So that's in flight. So we in flight we send a delta because we don't know that the clocks are in sync or that we're using even a common clock origin. So basically, you take the number of seconds in the packet and you subtract that from the current time on your clock, and that tells you roughly when the data was registered. In practice, it seems to be pretty accurate. So the idea is basically that you'll see these two timestamps, and obviously, I think we have a fudge factor in the document because you know obviously we're not going to be perfect. But you see these two timestamps, and if they seem like they're basically the same timestamp, then you don't have stale data.
Gotcha. Thank you.
That's correct. Just want to say I agree with what Stuart said about these things to suppress multicast traffic that you don't need. It sounds like something for the advertising proxy document. And maybe this TSR document could just have the basic definition for what is the format and what do you use it for approximately, and all those details for how to use it in the advertising proxy could probably go in that document.
So are you saying just the API changes relating to the stuff that we were just talking about, or all the API changes?
Yeah, I don't know. Whatever makes sense. I mean, I think if it's really related to advertising proxy, it would be strange to have it in.
The thing about the reason that I asked that question is because you know, we've had an advertising proxy for 5 years and we never needed this API. And the reason we never needed it was because we weren't doing the stale data stuff. And as our technology got better and better on the stale data detection side, suddenly it became clear that we needed this. So this really does feel like it's at least highly related to TSR, but you know, I think that's a legitimate point. And since TSR is going to be normatively required in the advertising proxy document, it's not like it's a problem. The only question is whether somebody would be implementing TSR and not advertising proxy, in which case it would be nice to have that documentation somewhere other than the advertising proxy document.
Yeah. And then maybe final remark was that we also have SRP replication document, and that kind of becomes important that if you combine a replication with multiple advertising proxies, that they don't start all basically advertising 10 times the same data. So I just added an issue on that. So like, how would we do that? So maybe that belongs in advertising proxy or maybe in the replication document. That's still a good question. Maybe it's in the advertising proxy actually, because that's where the advertising is defined. So
I mean, in principle, replication does not necessarily imply advertising proxy, although
that's
in
right.
practice it does.
That's why I think okay, thanks.
Thanks. So I think here what I'm getting a sense is this document seems critical for advertising proxy to work properly. It also seems to be in scope for our charter. But before we talk about adoption, Ted mentioned that his co-author on the draft changed employers and doesn't appear to have time to work on this these days. So we think having more than one author is always a good idea. We'd love to hear anyone in the crowd out, especially implementers, but not necessarily only an implementer. If you're interested in working with Ted on this, Ted's a great co-author to have. He has a lot of experience and he's nice.
Usually.
So I think it would be great to have someone join here as co-author. And even if you've never written an RFC, this is a great time to get started with someone with experience.
Yeah, I'll echo that. We have a growing team of people at Apple working on this, and it's great that our management is supporting us with that. It would be good to have non-Apple people cooperating on this as well, because we don't want this to be the all Apple show. So anybody who is willing to help, please do. And I echo what David said. If you've never done an internet draft before, publishing your first RFC with Ted Lemon as a co-author is a good way to learn that.
I hope that's true. If it's not, feel free to beat me up. Like, in other words, demand help. Don't just assume.
I'm fully supportive of getting another author. Do you know what needs to be done in the text? What kind of effort does it mean to represent? Because it's just to put another name, it's useless, right?
Yeah, I do have that concern generally. We don't want a sort of a pro forma co-author. I honestly, I think the document is in pretty good shape, but it hasn't had any working group review. So if somebody wanted to be a co-author and wanted to take, direction from the working group on what to change, I think that's a great way to learn to kind of start your co-author experience. So yeah, that could be worth doing.
Absolutely. Speaking for myself, my first RFC was with Stuart some number of years back, and it's a lot easier to start with an existing draft and helping out with it than staring at a blank markdown page. So I think, what do we think? Should we potentially ask for adoption and on the call on the list as well mention the request for a co-author?
I think ask on the list and we'll move on
Yeah.
to the agenda.
All right, we'll take this to the list for a formal adoption call. And if anyone is interested in co-authoring and has questions, please do not hesitate to talk to us or say so in response to the adoption call on the list.
Okay, so our next topic is DNS push additional data. Next slide. Why? So DNS push is basically our primary use case for it right now is replacing MDNS in cases where we don't want to use MDNS, but we do need the same kind of functionality. We need to be able to have sort of long-lived queries that see updates and stuff like that. With MDNS, if you do an MDNS query, the MDNS responder is generally expected to include relevant additional data. So like if you do a query on an SRV record, the expectation would be that you would get, in addition to that, you would get the text record, this is based on the DNSSD ID that the text record and the SRV record are pretty closely tied together, and you would get any A or quad A records on the owner name of the target of the SRV record. So the problem is that DNS push basically is a protocol where you say, give me everything you know about this name and keep me up to date. And everything you know about this name is, this name and this RR type. So everything you know about this name and this RR type is actually, there is no additional data section. But on the other hand, if you do a query for a name and you get some data back that's not on that name and has a different RR type, it's not an answer directly, so it must be additional data. So I think we have an opportunity here to solve this problem. One of the other things is if you send an MDNS packet with all of this additional data in it, the additional data often has common names with, the various pieces of additional data have names in common with each other. And so you get additional compression there. And so doing it this way reduces the amount, not only the latency, but also the amount of the absolute amount of data that gets sent, which is good, especially in the thread use case, which is one of the cases where we're using this right now. Next slide. Oh, that's a real eye chart. Let's see if I can read it. Sorry.
It's bigger right behind you.
Yeah, but then you'll get the I will not talk at the mic, and now I will talk, and I will not. I hate that. Okay, so this has been evolving, and I'm really just giving the working group an update on what's going on. I don't think this is quite yet morphed into being a working group item, although I think it's a lot closer than it used to be. So the previous version of the document, which I think is what's published right now, is kind of general, and we tried to do some stuff to make it a general solution that would allow you to do the things that I just described, but that actually probably isn't worthwhile, turns out, because DNS push, when we're using DNS push for DNSSD, that's a very specific use case, and there are very specific cases where it makes sense to return additional data and where it doesn't. For example, with MDNS, if you do a PTR query, that's multicast, and you're going to get a bunch of packets back from various responders, so like a bunch of different devices, each of which has one service, usually. And so that is going to be a relatively compact amount of data. And so including the additional records, so the PTR points to the SRV, points to the A and quad A, and also the TXT record. That's a reasonable thing to put in an MDNS response. However, if you have, let's say, 100 devices that have the same service type, and you do a DNS push query to look for PTR records, and you're really trying to find a specific device, that's going to be a massive amount of data, most of which will be garbage. So right now, the direction that I'm thinking this is going is that we actually get really specific and tune this to the DNSSD use case. If we have some other use case for this later, we can also come up with a solution for that. But for now, this seems like a clear thing. We could just have an option that we include. This would be an additional TLD that we would include that indicates that we want additional data. If we want additional data, then the server just gets the additional data, sends it to us in a single message, hopefully, and that gives us our compression. And then if there are updates, hopefully the same thing happens. We get whatever updates there are. If they're clustered, it would be nice if they all got clumped together into one update. And then, so that gives us basically the functionality that we're asking for here. Next slide. So I actually have a co-author on this who's very interested. This is Dima. And I think we're gonna do an update of the document, and so we'll share that around. I'm not in a rush to implement this, and so I'm not desperate for the working group to adopt this, but I think that this is topical and relevant, and I would like to see this work happen here in the not too distant future. So this is more of a, here's what we're doing, but also if anybody's interested in this, I'd love to hear from you. So I think that's it.
And the queue is open.
Esco.
That's correct. Just a question. So the DNS push updates, it's only to one destination, right? So it's unicast to one
It's unicast, yeah.
destination. So you would typically have one service of the type you're looking for. And
No.
isn't that
So,
the case?
so the use case for this for thread
Okay.
is that we have an SRP server.
Due to the recipe server. Yeah.
Yeah, and so basically you're going to do a query to the SRP server and you're going to get back an arbitrary number of services.
Okay. So that could be too much data. That's why you mentioned that 400 different servers plus additional data. Well, in that case, the server would probably not include it because it's kind of usually an optional thing that the server only includes when there is space and when it makes sense, right?
Yeah, but I think we do need to signal that we're sending additional data or that we want additional data, because otherwise, the client might not actually understand additional data, and then it's not going to know what to do with these records that are on different owner names.
Okay, yeah, that was in the draft that's mentioned as the TLV. So you mentioned that. Is that like an option or the TLV or?
So DSO has a primary TLV, which is basically what we're doing, and then additional TLVs, which are modifiers. So yeah, basically options.
Yeah, inside the option basically. TLVs.
So it's opt-RR, or actually no, it's not. It's not an opt-RR because it's a whole new packet format. So they're basically just TLVs.
Yeah.
So it's the TLV is just inside of the message. Yeah.
Okay. Yeah. Thanks.
Mm-hmm.
Any other thoughts? If not, we'll move on. Right. Aptin, do you want to?
Okay.
Yep.
Perfect. Perfect. So, and yeah, thank you. So I guess you will control the slides, right? Is that correct?
Sure.
Awesome. Thank you. Yep. So I'm going to talk about the SRP compression for constrained networks, and maybe a quick introduction of myself. My name is Aptin Keshavarzian. I have a PhD from Stanford in electrical engineering and almost 25 years of experience in research and development in networking, wireless, embedded software, and a bunch of other areas. And for the past 10 years, I've been at Google, Nest initially, and then Google, and have been working on Thread protocol, and one of the main contributors to OpenThread, which is an open source implementation of Thread. Yeah, thank you. Next slide. So background about what we want to talk about quickly here is about SRP, Service Registration Protocol, which is a DNS-based service discovery using standard DNS update messages with UDP and with unicast packets. SRP is adopted and used by the Thread specification. Basically, Thread-enabled devices use SRP to register their services, and the Thread border routers typically act as an SRP server receiving this. And as I mentioned, OpenThread provides SRP client and SRP server implementation, and there are other implementations. Now, on top of Thread, there can be a variety of different application layer protocols running. Matter is a common one, which is used for smart home type of devices, and it runs over Thread. And it's the one that uses SRP to register its services. It defines what service types it uses, how to form the instance name, text data, and other aspects of the service. Next slide, please. Yeah, a very quick update about Thread. Thread is a low-power, secure mesh network. It provides IPv6 connectivity. Underneath it, use some technology like 6LoWPAN for header compression, IP header compression, and QAP for thread management framework. At the physical layer, it's running over IEEE 802.15.4 at 2.4 gigahertz, with the data rate being 250 kilobit per second. And the physical frames over the air are limited to 127 bytes. So larger messages can be transmitted, but they will be basically using 6LoWPAN fragmentation, fragmented into a bunch of frames, and on the receiver reassembled back together. Yeah. Next slides, please. Yeah. So I'd like to start by looking at one example. This is actually an example from the field from a device, a Matter device running. And you can see this is the DNS SRP message that's captured. And if we look deep into this message, what's content of this message, is actually registering two services. You can see the blue and the green, the first lines are the service instance names, and both of them are the same type. Matter TCP is the service type, and one subtype which is included, and the other information associated with it, and the host name and one address. So a couple of things to notice that like Matter has this very nicely defined way of how to form or how to construct the names of the different things, now how to construct the service instance name. So you can see it's actually two 64-bit numbers represented in ASCII hex character. I believe the first one is notion of a node ID or network ID, and the second number is a notion of a node ID, or basically identifier of the device itself. Now, next slide, please. Yeah. Yeah. So if we look at this message is the UDP payload is 641 bytes, and below you can see the breakdown of where everything goes in this message. It's like 15 records total, 13 in the update and 2 in additional, and like the breakdown of the different records and what do they apply to. So you can see for each service we are using about 170, 190. The rule of thumb that we have seen is like something between each service adds about 150 to 200. Of course, it depends on the text data side, the names and other stuff, but that's a good like rough estimates of how much would be consumed per service. Next slide, please. So one thing to point out about this 641 bytes payload, this SRP message already is using DNS name compression, meaning if a set of labels appear in the message, pointer labels are used to refer back to them, so we don't repeat the same names. And the other thing that's used, which is somewhat SRP-specific optimization, is the key record optimization, which means that we include the key record only for the host name. So technically, we should include it for all the names, including service instance names, but the optimization allows us to include it only for the key record, and on the server side, it will automatically apply to every name contained in the SRP message. So this 641 bytes is already using those optimizations. Next slides. So what is the typical SRP update message size that we see, mainly regarding like use cases in thread along with Matter? So SRP itself is adhering to the DNS updates general format. So this introduces some overhead and can lead to larger SRP message sizes. And one thing to have in mind is that the devices may end up having multiple services, more and more services to register, and more addresses possibly to also register. One thing to highlight is like Matter itself has this concept of what's referred to as a multi-fabric, which allows one device to be part of multiple ecosystem. And how it's done, then it will be a separate service per every ecosystem that you are in. And there may be additional like vendor-specific services that the device wants to register and use, basically. As a rule, we see the typical SRP messages that we see from thread devices range something from 400 bytes to 1200 bytes. And if we look at this from the perspective of a faster, like higher throughput network, like if you consider Wi-Fi or Ethernet, the 600 bytes, 1000 bytes seems perfectly fine. But when we are talking about thread as a network with lower bandwidth, and more constrained network, having these larger messages can link to increased traffic. Especially a situation to consider is some synchronous event happens and triggers all nodes or many nodes to need to register their services, tens or hundreds of nodes registering together. Example of this is like the border router or the server rebooting and coming back up and saying, hey, everybody, I'm back, register your data. So there are certain mechanisms that are already in place. For example, there are jitters that we try to distribute it over time. But then the question becomes, can we do better here? Do we really have 641 byte worth of data in this message? Can we somehow compress this message? So next slide, please. Yeah, so that's where it's basically the idea come. Basically, the idea of defining an SRP coding mechanism. On the client side, basically, we encode an SRP message into a compact compressed format, reducing the size. And on the server side, the received coded message is then decoded to reconstruct an exact replication of the original message that we intended to send. So, and then this can be fed to SRP server. SRP server code does not need to be aware of that this was a coded message. Next slide. So going back to the example that we had, what's the savings, what's the compression rate that we can see? The same example from the two services before. So the original message size was 641 bytes. And if we apply this encoding mechanism, this coding mechanism on it, this can become 244 bytes. So 2.4 times smaller, which is a good, basically, saving regarding that. Next slide, please. So one thing to highlight, it might be useful to exclude key and signature records when we are doing this comparison, because we cannot really compress them. We have to include the raw bytes, the signature, and the raw bytes in the key, in the even in the coded message. So if we try to exclude that, we see that in original uncompressed message, 175 bytes is used for the key and signature, and then 465 remaining from the rest of the fields. And in the coded message, actually now more than half of the message is key and the signature. Now in the coded message, 128 bytes and 116. So if we exclude those and look at only the records that we are actually compressing or can compress, we see there is a factor of four compression happening here. Good. Okay. So next slide. So I won't want to go into the details of the coding mechanism. It's pretty straightforward mechanism. It's inspired by ideas from 6LoWPAN and some of the other mechanisms that try to compress data. At the core of it, it defines a SRP coded message format. It practically mirrors an SRP update message. It has a header. It's divided into a bunch of blocks, a header block, and then we can have 0 or more add or remove service blocks corresponding to the services, and then the host block where the addresses are encoded, and at the end there's a footer block for the leads and key leads and signature and a bunch of other stuff. And each block starts with a single dispatch byte, and that dispatch byte, the first few bits indicate what type of a block it is, and the rest of the bits define which fields are following after that, which fields are included in the block, and which fields are compressed or elided. Example of that is, for example, for service, we always have like a priority and wait fields associated with every service, but they are often 0. So there are bits that are corresponding that say, hey, if it's set, don't include these numbers, basically assume they are already 0. And then each block follows by the fields as defined by the flags or as defined by the type itself. Next slide. So one other thing that I like to mention is there is some optimizations also to compress and encode DNS names and DNS labels better. So we can still, similar to the the general DNS compression, we can refer to a previously encoded label in the message. So basically, we don't need to repeat the same labels. Some of the commonly used constant labels now get a specific code assigned to them that become a single byte in the coding. Things like UDP, TCP, even some Matter and other application protocols can be assigned and can be compressed efficiently. And the other thing is some of the, I refer to as a generative pattern. Some of the names, the way the names are basically constructed, they can also be encoded more efficiently. As an example, if the name is really a ASCII representation of a 64-bit value, there's a code board, and then we include the raw 8 bytes directly rather than the ASCII representation. Similarly, for other things, for the subtypes or for the service instance, which is now concatenation of 2 such names with a hyphen in between. Yeah, I think, and finally, yeah, as mentioned, so we have a, sorry, can you go back? Yeah. So we have an implementation of SRP coder available. I have the link for it and the pull request. The pull request in OpenThread below. It's implementation of both the encoder and decoder side, and it's already integrated into the OpenThread SRP client and the server side that can be enabled. And in particular, we made the decoder a standalone, so that's the idea being that we can use it with an external implementation if needed. And there's also documentation of the protocol and includes an extensive set of tests in this PR, covering a lot of corner cases, edge cases that can arise. As next step, what we like to do is that we want to adopt this SRP coder mechanism in the thread specification and deploy and test it. And assuming there is interest, I'm also open to considering adding a future IETF draft regarding this to have it be standardized, possibly if it's useful for other type of networks. Yeah, and I think that's my last slide.
Okay. Stuart.
Stuart Cheshire, I'll make my comment quickly because I know we have one more thing on the agenda. Thanks for bringing this, Abtin. One thing that I was thinking as you presented it, would be good to start with a slide about the scope of this. Is this just for SRP on thread? Is it for SRP generally? SRP is kind of a specialization of DNS update. Or could this be used for all DNS queries? Now, I think if we say all DNS queries, like the DNS op community is going to jump on us. And given your description of the encoding, it seems like maybe it's even more specific than that. It's really tailored for Matter using SRP on thread networks, which is fine. I think we should be clear about what is the scope we're targeting with this, because if it only affects thread networks, then the rest of the IETF doesn't get too concerned about it. If this might be used on Ethernet and Wi-Fi and on the public internet, then a lot more people are going to want to review it.
Good point. Just answering your question, it applies to SRP basically. So basically we can compress any SRP as defined today, not beyond, not a general DNS message, not a general DNS update message, but any SRP message, irrespective of like whether it's Matter or other type of service.
Eric Ving, so thanks for the presentation. I wonder what do you have look at something called SHIC, which is an IETF standards for compressing well-known protocol. It doesn't have any dictionary, but it's very similar kind of thing.
Mm-hmm. I didn't look deep, but at the start of this, I did an investigation of a bunch of things, and I believe I looked at what you mentioned as well. I did an investigation of a bunch of different ideas and see how effective they are. So our idea here was like to have something that's really efficient for the SRP format itself. So that we didn't deem them suitable for this particular use case, but yeah, there are many different ideas of realizing the same thing or similar behavior, of course.
Just to let you know, SHIC, SCHC, you can have very specific rules on very specific protocols. So rather than reinventing part of the wheel, you just write rules. But okay, it's up to you.
Okay, so we've got 8 minutes left. Would you prefer to discuss advertising proxy open issues, of which there are 4, I believe, or the Service B presentation?
So I looked over the open issues, and I don't think any of them are terribly exciting. And I think that there was some wish to do SVCB, so I would vote for SVCB.
We're getting some thumbs up in the room. Anyone to disagree with that? SVCB it is.
Hello, can folks hear me?
Yes, go ahead.
Awesome. Okay, so my name is Gautam Akiwate, and I work at Apple, and I work with Tommy, Stuart, and Ted. And basically, so the next slide, please. The basic scenario that we're trying to think of is when we have this custom service and we are able to sort of discover this custom service using DNSSD, and the discovery leads us to a host name and a port. And the thing with this service, this custom service, is that it's also expressible as an URI. Like, let's say we want to connect to it using HTTPS. But the key thing here is that the service is not of type HTTPS, but something along the lines of like custom transfer ._TCP. And the long and short of it is that the server on the local network, the service can receive both HTTP2 and HTTP3. And ideally, we would like to use HTTP3. But the question here is, if the server, but how do we signal support for HTTP3? So if the server does not support HTTP3, then how do we make sure that the support or the lack of support is signaled? And one of the proposals, one approach that we have thought of, next slide, is the use of SVCB records. So in this scenario, the SRV records will lead us to a host name and a port. And now, in addition to an AN quad A query that is typically run once we have this service, we would also like to run an SVCB query too. And the thought here is that the SVCB query would allow us to use the ALPN fields to signal whether the server supports H2 or H3, and thereby allowing us to sort of signal support for HTTP3 and also extend it in the future. So that is roughly what the idea is. Basically, the scenario is we have a custom service, we want to signal support, and the potential approach that we're thinking of is the use of SVCB records. We would like to sort of pull the room and see if folks have thoughts about what are the what people think of this approach, and if there are other approaches that people think might be suitable. And I see Stuart walking up to the mic, so I will let him talk to.
All right, thank you very much. Just to remind folks, we have 5 minutes left, so please keep your comments or questions short.
Thanks for presenting this, Gautam. For everybody in the room, I just want to be clear, this is nothing to do with thread and matter. This is a totally separate context here. So I know we talk a lot about thread in this group recently, but put that aside, this is totally different. And we'll be working with Gautam to put together an internet draft with some concrete idea. That's not done yet, but I asked Gautam to at least give this group a heads up about this issue. SVCB and HTTPS records are used for web browsers. This is a protocol that is using HTTP, but not to present user-visible web pages, like many things today, like Netflix streaming video is a bunch of HTTP gets. So that aspect of repurposing HTTP is not unusual. We'll discuss this on the list. We will have a draft to discuss, but we wanted to put this in people's minds. And particularly the interesting question here is, with traditional web browsing, these SVCB and HTTPS records are related to the host name of the target host. With DNS Service Discovery, we actually have a more specific name. We have the service instance name. So maybe it makes sense to attach the SVCB record there instead. And that would be a slight change in how SVCB is being used. But having read that 47-page RFC, to me, that seems like maybe a better way of doing it, because a bunch of the complexity in SVCB is you have a bunch of things colliding on the same host name, and you've got to put underscore port number and various things to disambiguate them. If we start with names that aren't ambiguous in the first place, we don't need to intentionally ambiguate them, so we can then disambiguate them again.
Tommy's up next. Hello, Tommy Pauly, Apple. Again, I think just giving a bit more context here. I think the first approach that we're looking at taking is to try to describe this without having to modify any of the protocols. So the way SVCB is set up, it is expressed in terms of a URI. So like it can have a port, a host name, and a scheme. Those are all things you can have at the end of a DNSSD resolution. And so this is just another thing you can tag on in order to get some of the other attributes that come along with SVCB that are already defined normatively, like ALPN information. So one approach here would be to say we can get ALPN type information without any normative spec changes. We just need an informational draft explaining how you can combine the two sets of queries and do them in the correct order. Stuart was pointing to, like, you could have other approaches that do require normative changes that are variants that kind of use different identifiers or try to replicate the ALPN information or the parameters in other types of resource records. All of those are possible. So I think what we'd be curious to hear feedback on is which of those ways of putting things together do we like the best?
do we like kind of the cleaner document approach where we don't have to make normative changes, or do we want something that's a bigger change? And also where that work should happen is, this is specific to this local network peer-to-peer DNSSD style thing. Is that work that this group would be interested in working on? Or is that something, I mean, clearly we need to coordinate with DNS op where SVCB is from. So those are the questions we'd like people to talk about on the list as we work on this.
Thanks. And so since we have 1 minute left, I'm going to say, let's discuss on the list. So I'm going to give an action item to the proponents here to write this up in a bit more detail. I think the presentation really helped, but having something written down that people can refer to will help. And then we can kind of review and discuss our options on the list. If this ends up being here's how you use DNSSD to do this, it could be in scope for this working group. If this is we need to change SVCB, that would have to go somewhere like DNSOP. So I think let's start this conversation here, and I'm sure we'll loop in a lot of the DNS enthusiasts that might not necessarily be in this room, but are in this building.
Do you want to share something now, Chris?
Yes.
Because it's maybe the same thing.
So, so I just wanted to say thank you to David for chairing this working group for 7 years and more. So yeah, just some memories of David at the chair table for many, many meetings. And you can also see Tim there, actually both Tims, and Barbara, of course. And it goes on because then we had COVID and we had various online meetings, and then yours truly joined the table. But yeah, David's been through all of that and steered this working group through. So thank you for that.
Oh, thanks. That's awesome. And people can realize that I decided to stop shaving in March of 2020, and it kind of never stopped.
Okay, thank you. Just one last addition. The Anima working group chair told me that he will be sending to the group a document from Anima, but with a DNSSD component on it, asking for a cross-working group review. So just be warned. I would love that some people have a quick review on the DNSSD part of it. Thank you.
Wrap it up.
Yep. So that's it. The meeting is finished, and all right. There you go.
And that's all, folks. See you on the list, and I'll be in the room on the other side of the room next time. That sounds fun. That's really funny. Thanks for doing that. Wow. Yeah, that brought back quite some memories.
Yeah.
I haven't heard from Barbara since she retired. I hope she's doing well.
No, I've not. Yeah.
So there was some session in Brisbane? There was one. Oh, you know what it was? It was joint snack. Oh, yes. So it showed up as a snack. Yes. So I missed that. Yeah, that's all good. That was really funny to go back.